Greetings, my friends. Before you start on your IXL today, I'd like to go over a couple of problems to give you sort of a video companion, somebody to hang out with and teach you a few things. So let's get started. Okay, so we're just going to look at a couple of examples that you might encounter in the IXL. This is an early on type of problem where the elimination is easy because what you see here is that in this particular problem, that you get positive 2y in the first equation and negative 2y in the second equation. It's already all set to eliminate. No need to multiply through by anything. And you can just add the first equation to the second equation. So you can add the 8x and the negative 2x, giving you 6x. The positive 2y and negative 2y already cancel out. And the 20 and the negative 14 equals 6. And then we solve for x and get that x equals 1. Next, we take one of the original equations, such as the 8x plus 2y equals 20. I could have also used the other one. It don't really matter. It's up to me. And I'm going to take that 1 that we just got, and I'm going to plug it in where the x is in the equation. So x equals 1. So I put that 1 right here. 8 times 1 is 8, plus 2y equals 20. And then I just continue to solve. I subtract 8, 2y equals 12. And if I divide by 2, I get y equals 6. So my final answer is that my x is 1 and my y is 6. And that is exactly what I would enter and submit. As you progress through the problem, they're going to get a little bit harder. In this particular example, the numbers are not already opposites, so I have to make some decisions. Now, in this particular problem, the x's are pretty ripe for being eliminated, but they're not quite there because I have like a negative 8x and a positive 4x. So I actually can multiply just the second equation by something so that the x's become opposites, because that's ultimately my goal. I want either the x's or the y's to become opposites. So I say, you know what, I'm going to keep the first equation exactly as it is. So it's going to stay negative 8x minus 4y equals 16. But then I'm going to multiply the second equation by positive 2, because 2 times 4x equals 8x. And now my x's are opposites. Then I'm going to multiply the 2 by the 3y, giving me 6y. I'm going to multiply the 2 by the negative 6, giving me negative 12. Whole idea behind this is now I can cancel. Negative 8x, positive 8x, they cancel out. Negative 4y, positive 6y, that equals 2y. And 16 minus 12, that's 4. Divide both sides by 2, and we get y equals 2. Again, that's the first half of the solution. So now I take either one of the original equations. I'm going to choose 4x plus 3y equals negative 6. It's got less negatives, so I'm making the assumption that's going to be a little bit easier. And I'm going to take that answer we just got, that y equals 2, and I'm going to put it in where the y is in that second equation. So right here, I get 4x. 3 times 2 is 6. I subtract 6 from both sides. 4x equals negative 12. Divide by 4. X equals negative 3. So negative 3 is my x. Positive 2 is my y. Boom. I submit. I got it. Bada bing, bada boom. I'm all set. One more example. I don't actually have to on this problem, but I'm going to do it so I have to multiply both equations by something. So I might look at the x values and say, what number do 6 and 2 both go into? Now they do both go into 6, but I'm going to say, let's just to make it a little bit more interesting, 6 and 2 also go into 12. So I don't want them both to be 12. I want one of them to be positive 12 and one to be negative 12. That's the only way they're going to cancel out. So I'm going to look and say, you know what? I'm going to multiply the positive 6 in the first equation by positive 2. That's going to get me 12x. And I'm going to multiply that entire equation by 2, which is what I've just done. I've multiplied every element of the first equation by 2. Now I take a look at the second equation here and say, okay, I don't want it to be positive 12. I want it to be negative 12. So I'm going to multiply the second equation by negative 6. Because negative 6 times positive 2 is negative 12. Okay, so I've multiplied every element of the second equation by negative 6. Got negative 12x, positive 6y, and positive 48. And now I'm going to add down the columns. These cancel out, which was the whole point in the first place. And then I get negative 20, positive 6, which is negative 14y. And then I add 36 and 48. 8 plus 6 is 14. Carry the 1, 84. I divide both sides by negative 14. 84 divided by negative 14 is y equals negative 6. Just like the other problems, I'm not going to take that negative 6 and plug it into either one of the original equations. So I chose the first one. I'm going to do 6x minus 10, leave the y blank. And we got y is negative 6. I plug in a negative 6 where the y is. And I have negative 10 times negative 6, or at least that's how I like to think of it. 6x plus 60 equals 18. Subtract 60 from both sides, and I get 6x equals negative 42, and divide by 6, and I get x equals negative 7. So x equals negative 7, y equals negative 6, and that's it. I have got the answer. What a very satisfying ending to a challenging problem. So, just like last time, I want you to do the best you can. Try to do 100 smart score, because that's obviously like the best possible situation. Or do 35 solid minutes of work. Thanks a lot. Hope it goes really well for you. If you have any questions, drop me an email.